Key feature of a continuous X-ray spectrum. The spectrum has no sharp peaks. So that means sharp peak means the spread of the wavelength will be narrower. So instead it spans a range of wavelength, right? So it spans a larger range of wavelengths or energy or frequencies, right? So the minimum wavelength, right? So the lambda minimum depends on the maximum energy of the incident electrons. That means the outcoming wavelength, the minimum wavelength is dictated by the voltage, right? The voltage, applied voltage. So the remaining factors are constant. So the minimum voltage formula is this. So the minimum wavelength, X-ray wavelength formula is this. Lambda minimum is equal to hc by ev. So here h is Planck's constant, c is speed of light, and e is charge on the electrons, and v is the applied voltage. Therefore, the only factor which controls the wavelength of the emitting materials or the emitted X-ray wavelength is dictated by only the voltage, applied voltage. So that means the voltage is the only controlling factor. By varying this voltage, the required lambda can be obtained, right? So that means the required wavelength of the X-rays can be obtained by altering the voltage, applied voltage to the electrons, right? So or by, in other words, by changing the energy of the electrons by controlling the applied voltage, so one can tune the outcoming a continuous X-ray wavelength, right? So in other words, EV can be also called as the energy of the incident electrons. So that depends primarily on the voltage.